Hi, and welcome to the 5th episode in the Sienna training series. I'm Kate Doubleday, and we'll be showing how to parse data sets from other tools or other sources into Sienna Data. Sienna is an open source platform for power system modeling, simulation, and optimization with 3 core applications. Sienna Data focuses on efficient data input, analysis, and transformation. Sienna Ops enables system scheduling simulations by formulating and solving optimization problems, like unit commitment and economic dispatch problems. Sienna Dyne enables system transient analysis, including small signal stability and full system dynamic simulations. Each of these 3 applications uses a combination of packages written in the Julia programming language. And today we're focusing on Sienna Data and in particular PowerSystems.jl, which is sort of the foundation and powerhouse of Sienna Data. So first, let's quickly review Sienna's approach to data, which we introduced in the video on how Sienna Data works. Sienna has well-defined data models that hold the static and time series data for each component type in a power system. These data models can be populated with inputs from a variety of different data sources and different data formats, and that parsing process is the focus for today's video. So there are 4 different data sources that we'll talk about today that can be used for different applications. The first is a power flow case from either a mappower.m or psse.raw file, which could be used for power flow modeling in Sienna, or as the foundation for production cost modeling with additional operational and economic data added on. We'll also talk about parsing PSSE dynamic models from a .raw and .dyr file, which of course is most suitable for dynamic simulations, could also be used for power flow simulations. We'll talk about parsing your own CSV data files for power flow or production cost modeling. And finally, we'll talk about parsing a Plexos model from a .xml file, which could be used for power flow if the Plexos model has impedance data included, or for production cost modeling in Sienna. These first 3 options include capabilities natively in Sienna Data, but we'll also talk about an additional package written in Python called R2X, which enables this Plexos translation. Before we go into each of those 4 options in a little more detail, I do also want to share that generally, regardless of the option, there are some automatic validation capabilities enabled in Sienna. So if you use Sienna Data's built-in parsing capabilities, that will automatically check for valid data ranges and units. Once you run a parsing command, you might see hundreds of lines of print statements, and those can include info, warning, and error statements from the parsing process. So this is a great thing to review if you're seeing anything unexpected or having any issues with your data. Take a look at the print statements. The goal is not necessarily to remove all issues with warnings if some of them might not matter for the type of modeling that you're trying to do, but it's a good first place to look if things are not looking as you expected. So let's go through each of those 4 options in a little more detail. The first one was parsing data from a power flow case. So this is from either a .m or .raw file. It's a single command to run this parser. This will import topology and generator information, but there are a couple issues to be aware of. The first is that folks do a lot of hacks in PSSE. Sienna will not understand or anticipate any hacks in PSSE models. It will parse data as is. So, for example, if you have turned a generator off by isolating its bus during a snapshot in PSSE, it's then the user's responsibility to turn that on again to make sure that all buses and generators are included in, for example, a production cost model that would have multiple time points, not just that snapshot. Another issue is that PSSE does not require unique bus names, but Sienna does. So there are examples in the PowerSystems.jl documentation for handling unique bus names to update redundant names coming from PSSE. And I'll put a link to that in the description. So this is great to use as a foundation for production cost modeling, but you would need to add and augment the system with additional data, including generator costs and time series data, to expand a single snapshot to a full production cost model. If you're interested instead in dynamic simulations, then we're moving on to the second option, which is parsing from PSSE.dyr file. This is an extension of the previous method where we include both the PSSE.raw file and the auxiliary dyr file that includes the dynamic generator and inverter data for running dynamic simulations. Like in the previous case, it has the same two common caveats, along with the caveat that not all PSSE models are available in Sienna, not all PSSE Dynamics models. So PSSE has many, many Dynamics models. Sienna only implements a subset. The most up-to-date information on what models are available can be found in the PowerSystems.jl documentation by checking the subtypes of dynamic generator component. But we're also listing here the currently available dynamic models as of June 2025. This list is always changing as we continue to develop, so checking the documentation is the best place for the most up-to-date list. Also note that there are some caveats here about data models that can be parsed by Sienna Data, but the dynamic model is not available in Sienna Dyn. There are some recommendations on generic inverter models that are available in both applications. All right, so if you don't already use PSSE, MapPower, or Plexos, the option to consider is parsing data directly from CSV files. This can be from any source that can be organized into CSV files. It's the most flexible process, but it's also the most intensive. If you are using PowerSystems.jl versions 5 or earlier, there is a function available called PowerSystem Table Data that can help with this, but it requires a lot of data preparation and specific file formats. In addition to the CSV files themselves, this requires some input YAML and JSON files to tell Sienna how to do the parsing. We do plan to deprecate PowerSystem Table Data in future versions. Given how much customization is already required, we recommend to write your own code to loop over your CSV in the current format that it's in, rather than trying to reformat to this. So we've written an example how to do that, and I will also link that into the video description. All right, so now let's talk about the fourth option, which is using this additional package, which is not strictly part of Sienna, but also developed at the National Renewable Energy Laboratory, R2X. R2X was originally developed to help translate among NREL's open source tools, including back and forth from reads, which is a capacity expansion tool, into Sienna, and from Sienna into PRAS, the Probabilistic Resource Adequacy Suite, and also includes capabilities of translating from Plexos into Sienna. While we're talking about additional integrations, we also want to mention that there are a couple others that are in process. We are developing an integration with the capacity expansion tool Engage, and have also just begun development on integrations with GenX and PIPESA. But for our users who currently have models in Plexos, we want to share the availability of R2X if you weren't already familiar, and what the currently supported versions are. So this can parse Plexos databases in Plexos versions 9.0, 9.2, and 10 into PowerSystems.jl 3.0 and 4. This is a Python command run from the command line with various arguments and YAML configuration files. R2X has its own documentation, and so I'll also link that in the description below. So that's what we wanted to share in this video. We didn't go into detail about how to parse additional time series once you have your foundational system from one of these 4 options. There's another video that helps introduce the various time series formats. And we also have in the same example for parsing CSV files for the static data, some examples for how to parse in time series data as well. So I'll put that in the video description. Thanks very much, and we'll see you in the next one.